Okay guys, one video for Algebra 2, and this is going to be like stream of consciousness, one take, no stop, all my mistakes caught on video. We've been talking about functions, this idea that like y equals some function of x. That x, we plug in values of x, we get certain y values, and we have a function. We are going to look at this idea of transformations. So you can take a function and you can transform it by having a value that you multiply the function by having a value you multiply the x by adding and subtracting a value from x, or by adding and subtracting a value to the y. So we are going to look individually at each one of these things. We're going to look at what does adding to x, what does adding to y do? What does multiplying the y value do? What does multiplying the x value do? This is a huge idea, and it will be at play with every function we ever talk about going forward from this point on in the year. So this is not easy, and I understand it's going to take some time, but we're just introducing some ideas right now. So take a look here. If you take a value k, and it is added to a function, it moves the function up. If it is subtracted from the function, it moves it down. Now that should make sense from y equals f of x. If I just subtract some value out here, or add some value out here, I'm just changing the y by that value. The y value is going up or the y value is going down. So you can actually just move a graph up and down by adding or subtracting outside. Now this is interesting, and we'll get into it more together, but it's the exact opposite with the x value. With the x value, adding moves it to the left, and subtracting moves it to the right. The way I think about that is take this value of 0. If I change the inside, so we have y equals f of x. How do I get a 0 for x? I plug in 0. But if I have y equals f of x plus 2, how do I get a 0 inside here? I plug in a negative 2. The negative 2 is acting like 0, so it's actually moved backwards 2. This positive 2 is actually now where 2 is. This positive 1 is where negative 1 is. The values have been shifted backwards by 2 because I've added 2 to everything. So to make this work like a 1 inside here, I actually need to plug in a value of negative 1 to make this a positive 1 inside. And then when you subtract 2, it moves to the right. So it's the exact opposite for x than it is for y. And that's going to be true somewhere else in this next slide. We have reflections, which I don't focus too much time on because a negative value here and a negative value here I'm going to deal when I talk about the number, but it is worth looking at that a negative value here flips all the y values, which in effect reflects it over the x-axis. What was once positive is now negative. What was once negative is now positive. So it flips over the x-axis. This one I think is actually really cool. Negative on the inside flips it over the y, because it takes an x value like positive 1, and now negative 1 is acting like positive 1. And negative 2 is acting like positive 2. And positive 1 is acting like negative 1. Then we have stretches. Oh, sorry. So with stretches here, this is another place where you will see the reverse. Let's talk about a value being multiplied outside the function. That will actually stretch the function by a power of 2. It will stretch this up twice as high, or it will make this twice as small depending on what the value is. So a 2 out here stretches the y values by a factor of 2. when you multiply by the x, a 2 inside here will actually change it by a factor of a half. So now this 1 is acting like, a 1/2 is acting like 1. So think about f of x and f of 2x. It's that same idea. What do I need to plug in for x here to get a 1? I need to plug in a 1/2. So the idea here is when the value is large, so when q is bigger than 1, it's a horizontal compression. If q is smaller than 1 but bigger than 0, it's a horizontal stretch. So I look at f of 1/2 x, that would actually give me, what do I need to plug in here for x to get a 1? I need to plug in a 2. So that actually stretched this function. Good? So I know this is a lot of information. Look at this again, and I'm going to ask you to do a couple things on your calculator. What I'd love for you to do on your calculator is to graph these functions. Y equals x squared, y equals 2x squared, y equals 5x squared. Watch what happens when you plug a 2 here and a 5 here. Then graph y equals 1/2 x squared and y equals 1/5 x squared. And look what happens when you have these different numbers. Then I want you to graph y equals x squared plus 3 and y equals x squared minus 3. All of those, and you can graph them 2 at a time. So graph this function and don't erase it. Then do y2 and y3 with these functions. Then maybe add y4 and y5 with these. And then you can get rid of all of those. And then y2 and y3 here. And see if you can look at how this function is being transformed by these different values. After you've played with those for a little bit, I would love for you to play with the x. So then graph y equals 1/2 x squared. Or look at y equals 5x squared. And then after you're done looking at those, maybe take a look at y equals x plus 3 squared. Or y equals x minus 5 squared. Always keeping the parent function on your graph. This is the function that's being transformed here. And so that's what you want to look at, how these transformations work. Then you can look at y equals negative x squared. Unfortunately, with x squared, there's no difference between that and this. Well, there's a slight difference, yeah. This will flip it down. This will flip it over the y-axis, which looks exactly like itself. So after you've done that, you could play around further and change it from x squared, and you could make it something like y equals x to the third. Or if you wanted to get real crazy, you could do y equals x to the 1/3, and then you can do all these same transformations again and see how those things play out. Tomorrow you actually get a chance in class with me to play with your calculator quite a bit and explore function transformations. We are not going to fully understand this unit by the end of class tomorrow. This is going to take really days and days, maybe even months before you fully master this. And even then, it's something that I continue to see and understand at a deeper level with each year I teach it. So this is a huge concept, and it's something that you'll deal with all year. Shout out to Nelson, Eli, Daniel, and Ten hanging out with Charlie, doing some coding today. Peace!